Hello, everybody, and welcome. Hope you all are having a great time at AWS reInvent, and thanks for joining our session today. Today, we are going to be talking about how the AWS marketing analytics teams uses the AWS platform to automate and scale our analysis and help serve our global marketing team, which is a truly global team which sits all around the world. So I'll start with some introductions here. My name is Amit Prakash. I've been with AWS Marketing for a little over 5 years, and I run a few teams within the marketing organization. I run all of our advertising teams, all of our analytics teams, and I also manage a small marketing operations team. And I'm joined today with my colleague, Nilesh Gadani, who runs our data science team, and his team is responsible for two major functions. One, how do we set up methodologies to measure the impact of marketing campaigns on the AWS business? And also, how do we predict user behavior so we can target our customers and users with the right message at the right time? So that's who we are. And I'll get into what to expect from this session. What we'll be talking about is the journey that we took on building the infrastructure that has helped us scale and automate all of these analyses. What are some of the challenges we thought we had and how we overcame those challenges? We'll talk about some of the business applications that we've built that allow our customers, who are the internal marketing teams, to get to the data that they have, identify the trends, and help improve our customer experience. And we'll pick two problems which required scaling and automation, which Nilesh is going to talk about, and he'll go deeper into the architecture of how they picked the right building blocks to build those platforms. And then we'll talk briefly about what's next in our journey. So big data has become we are all living in the era of big data and has become the new norm. And we are collecting data about customers at pretty much every single stage of their lifetime. And as we have also moved more digital, there's a lot of other data that we are collecting, which requires us to have scalable compute and storage and databases. And some of the ways how we are collecting this data is even when you guys are attending large summits or even AWS reInvent or other digital channels, like how are customers coming to our website, when we engage with other marketing channels like email or social media, or even when people are searching about specific terms on popular search engines like Google or Bing, and how do we measure how customers get to the site and the interactions on the AWS properties. So that was one of the challenges we had. How do we ingest all of this data, connect them, and use that to provide a better experience for our customers? As I talked earlier, data has become like the center of customer lifecycle and also in product management. And we are using this data in multiple stages. And we like to call this into 4 different stages, which forms a virtuous cycle. So data collection, we keep collecting data from the click stream, which is also known as web analytics, using different channels where we measure the user activities, user-generated content, and also how people are using any products or purchases or social media. So we are in the stage of collecting data at various stages. Once we have more data, we are able to do better analytics. And by better analytics, I mean first building better dashboards and giving access to our end users with better reporting, and also which helps them dive deep to understand the trends and the hows and whys of what is driving the change in any specific business. And as we are collecting more and more data, we are also able to use that data as training sets to make predictions on the user behavior and provide better optimization and personalization of our products, which ends to leading to better products. And once we have better products, it leads to more users. We acquire more users, which leads to also adoption of existing users. And then the cycle comes again. Once we have more users, we get more data, we have better analytics, better products, more users, and this cycle keeps going on. So without further delay, I want to move on to the journey that we have had in the marketing analytics team at AWS Marketing. So I like to break that into 3 distinct stages. So the first stage was in 2012. And some of you might wonder why 2012 versus AWS has been around for over a decade now. So around 2012, that was the time when we got really serious about marketing analytics. And that's when we realized that we had a few challenges. We realized that we had data in silos. We had not connected our data, and we had not created a journey of our customers. We found a lot of data integrity issues where we had not set up the tracking correctly. We were not collecting data in the right way. We didn't have any reporting buildup or any front-end interface for our end users to be able to pull reports and understand what was causing the changes in the trends. And we weren't able to do any complex analysis because of all the things that I mentioned before. There wasn't a single data source to do the analysis. So we were only looking at very simple metrics like traffic and maybe self-service signups that were driving through the website. And that's where the second stage came, where we walked through which was from 2012 to 2016, where we started addressing some of the problems that I talked about that we identified in the early stages in 2012. So first thing was to build a single data repository where we had to ingest some of the existing data sources that we have, which we owned as first-party data. And then we also were working with other channels that we started investing in, marketing channels like paid search or social media or email, where we had to bring in all of their data and stitch together to build a single journey of our customers. And once we had this data, we started building dashboards and reporting, which allowed our end users to start pulling some data. And then finally, we also started moving from simple analysis to a little bit more complex analysis to understand the impact of marketing programs on the AWS business. And in order to understand the impact of these marketing programs, we took the approach which is commonly known as a test and control methodology, where we would pick a cohort of customers who were touched or exposed to a marketing campaign or a program, and then compare to a very similar cohort of customers who were not touched. And then we would measure the difference in the incrementality that we saw in these two groups of customers. But the challenge, even at this time, was that this was very manual. It would take weeks, if not months, to do some of these analyses, and we were not able to scale. And we conduct a lot of campaigns, and we weren't able to measure them. So that's where we've invested a lot in the last 18 to 24 months in 2 big areas. First was automation. How do we automate all of these marketing analysis that Nilesh's team had been working on and defining the methodologies? And second one was, since we had been collecting good amount of data, how do we use that data for predicting the user behavior and in communicating the right message at the right time? And one more thing which is very common in marketing organization is attribution strategy. How do we give attribution to a particular channel or a marketing touch in driving a specific business outcome? And a business outcome could be driving new AWS signups or driving the adoption of a specific product like S3 or EC2, because these are all complex decisions, and each of one of our customers is getting touched by multiple channels versus being with a single channel. So we wanted to make sure we are giving credit to the fair credit to each of the channel which is touching the customer before either converting to a new customer. So in the next few slides, I'm going to talk about some of the business applications that we built. So once we had our data available, what we started doing was, so taking a step back on the single data repository. So Amazon Redshift was the solution that we picked for building our data repository, where we ingested data from our web analytics systems, our billing, where we are able to get the usage and the revenue data that we have, from our CRM system, where we host all of our leads, from social media, advertising, And we can actually continue to grow our data warehouse by ingesting more and more data. And once we had data available, we started building business applications on that. And these are some of the applications that we built. I'm going to talk in detail on some of these, and I'm going to leave the marketing ROI and the machine learning for Nilesh, as he's going to go deeper into those two applications. So let's start with KPI alerts. This is a system that we built in-house, which actually allows the end users to set up alerts when we see their specific metric deviating from the average variance. So what this tool does is it allows users to set upper bounds and lower bounds for a bunch of metrics. It could be the number of signups or traffic or the number of first trials for a specific service. And when we see that it has deviated, either it has gone above or below, they get an automated alert and allows them to dive deep into what would have led to that. We also started building analytical marketing programs. And specifically, most of them were more digital marketing programs because it is very easy to tie the output to the input. And to the output, I mean an AWS sign-up or adoption of a specific product. And you can easily tie that back to an input. Say if we are using a paid marketing channel for that, we can tie that to the dollar amount and also optimize it to make sure that we are getting a positive ROI in terms of the investment that we are making. Some of those things we found very successful for us in these digital programs, as all of them were highly data-driven. And the next slide, we'll talk about some of the dashboards that we built, and we use Amazon QuickSight for that. And the reason why we wanted to build these dashboards were two things. One, we wanted to give the power to our end users so that they could build their own dashboards, and also the ability to slice and dice the data and understand the underlying trends. So as an example, if we saw a spike in signups in a particular region or in a particular country, we wanted the users to be able to go dive deep, to drill down into which campaign drove the increase in signup, or was there any other business trend that happened? Was there any press announcement, or was there an event that happened during that time which led to that? So with that, we are going to talk about the other two applications, and I'm going to pass it on to Nilesh, who's going to talk about the marketing ROI and machine learning.
Thank you, Amit. As Amit mentioned, there are multiple applications that are running from this single data source, which is Amazon Redshift. So anybody who works in measurement strategy, they know RCT or randomized controlled trials or A/B testing is the gold standard for measurement. But not every marketing campaign you can set up as an A/B test or design of experiments. So that's where we start to look into some of the observational study principles and build analysis or do analysis to measure the ROI. So the first application that we are going to talk about is marketing ROI, which is a multi-stage econometric model where we deploy advanced matching strategies to build a lookalike cohort of customers to compare the performance. And why do we need that? It means we want to make sure that marketing end users can measure the performance and then optimize their investments. And we want to make sure that we are doing the right campaigns that our prospects and customers find it useful, educational, to be able to adopt AWS. Now, if I were to ask you a simple question, whether this line is a small or long, or short or long, you cannot answer until you have another line drawn next to it. So you really need a good benchmark to compare and measure the performance. And that's where we use these econometric models to build those benchmarks and assess the performance. The second application is machine learning applications that we have. We use a lot of the user behavior data to segment our customers and then deliver targeted content based on that behavior. One of the examples that I can talk about is many of our customers, they come to AWS with a specific business use case in mind. And some of those customers, they do tell us their business use case, such as IoT, website, web apps, storage, gaming, but many of our customers don't. So we use ML to predict the business use case of our customers so that when we are sending content to them, it is relevant to their specific use case versus something irrelevant that they don't find it useful. And there are significant benefits of delivering personalized content. First of all, it significantly improves the customer experience because we're delivering target content. Obviously, it reduces churn, such as email unsubscribes and stuff. And on our end, it also helps us optimize the limited marketing inventory that we have. However, with both these applications, we started running into some issues. So the first problem was that this marketing ROI analysis, it was not scalable. It was 1 to 2 weeks of manual effort, which involved data collection, preparation, outlier detection, multiple econometric models, and we were also running up to 1,000 simulations to make sure that we don't have a small sample set of analysis to base our results. And with the growing marketing organization globally, this became unscalable simply because there were more and more number of requests that were coming in. We needed to prioritize those requests. Many of the requests we were not able to fulfill because we had to do this manually. And this problem was compounded as the marketing organization was growing globally, and then we had to coordinate across different time zones. So that was the first problem. The second problem was the automation. We were not able to run any of the ML models unless we do automation. We needed to run these models on a daily basis so that we could build those segments, send it to the downstream systems for marketing users to use those and run their targeted campaigns. So these models also require significant compute capacity for a very short period of time because we also needed to meet the SLAs so that the data is available downstream in the downstream systems. So we needed an infrastructure solution that could solve both our problems and help the team scale and help our stakeholders and internal customers. So what we started with is, hey, let's note down some of our key requirements for this solution, and then we can figure out how to build that solution. So in this slide, I'm just going to talk a little bit about what were some of our needs. So the first thing that we wanted to build as a solution was as a self-serve, on-demand solution that would help us serve all our marketing users. So the marketing users can come in and then they self-serve and submit the request, and then we will take the request and then process it in an automated fashion and send back the results of any of the marketing ROI requests. The second need was that we wanted this system to be agile. Means, as we mentioned, this analysis was taking 1 to 2 weeks of manual effort, and then obviously it needed to be prioritized. So there was a lot of latency between the request and when we were sending these, or when we were able to run these analyses and send the results. And then that's where we wanted a system that was agile and that was able to process their request in a short period of time, in a matter of hours, and send back the results. Oops. Sorry. The third need that we had was that the system needed to be elastic. Because we have a lot of ML models running on a fixed schedule, there was a significant compute need for a short period of time for peak workloads, and on off-peak period, there was not enough compute need. So we wanted to make sure that our system can auto-scale with the need of the workload. The fourth piece, which I think is a fairly universal requirement even in a small, medium, and large organizations, is security. We wanted to make sure that the solution is secure and it meets the IT security compliance that we had. So we used a lot of VPC features and encryption that is available with AWS services to be able to meet the security requirements. And the last one, we wanted the system to be easy to build. Due to scarce dev resources, we wanted to make sure that we are able to leverage the strengths of the data science team that we had. So with all these requirements in mind, we built a platform on AWS which we are going to talk to you guys today. So before going into the platform itself, I want to discuss the 3 key building blocks. Amit briefly talked about Amazon Redshift as a central data repository where data from different sources is collected, integrated, and available for any downstream analytics. To handle our key needs, we also chose Amazon EMR for our distributed processing needs, which also allowed us to handle data manipulation as needed, and obviously could auto-scale for any peak workloads. The third key building block was Amazon S3, which allows us to store various inputs, scripts, outputs, and has high durability and availability. Some of the key features of Amazon EMR that we used that helped us a lot, we chose Apache Spark as a distributed framework on EMR. There are a few features that made this a great choice for us. It is massively parallel, natively supports multiple languages, including Python, and it is tightly integrated with Spark ML libraries. There are other benefits of Apache Spark and Amazon EMR that other reInvent sessions will do a great deep dive on. So if you are interested in some of those, I would highly encourage you to check out those sessions. Moving forward, we also set up a one-node cluster, which was a persistent cluster to have always available computing resources for any on-demand analytical requests that marketing users were submitting. It also helped us reduce the latency in spinning up a new cluster every time a new analytical request would come in. Another feature of that we were able to leverage was EMR-FS, which is an implementation of HDFS. It allows the cluster to use Amazon S3 to read and write the data. And then it helps us also decouple storage and computing resources. It also allows at-rest server-side encryption to meet some of our security needs also. As always, security is important and always at the front. We needed to meet some of the internal IT security compliance, such as EMR has to be in private subnet, data encryption, at rest, and in transit. And then, but one of the things that we want to caution, there are multiple options available. For example, how you set up VPC with public-private subnet, how you do security groups, inbound, outbound rules, encryption policies, and then even IAM policies to control the access. But you need to know the options that you need for your work. So I think one of the things that helped us significantly was available reference resources such as documentation, past reInvent sessions that we were able to leverage a lot, and then helped us guide through the needs and needs that we had and how we meet the security compliance. So this is just going a little bit further deep dive into EMR Cluster Security. We have our EMR cluster sitting in a private subnet, which is a very common configuration. We use VPC endpoint to Amazon S3 to directly access data from private subnet. And you also have flexible IAM policies, both at VPC endpoint and on S3 bucket, to be able to have a fine-tuned access control based on your needs. We also use NAT gateway to access other services that have public endpoints, such as retrieving KMS keys, etc. Going further, this is a screenshot from EMR console. This is to define security configuration, predefined security configurations. You can predefine these security configurations, and when you are launching a new cluster, you can just call this, and then it will create the cluster with these security configurations. For example, we used AWS KMS for at-rest encryption in S3. We also use local disk encryption using KMS for HDFS schema, and we had in-transit encryption by providing encryption artifacts as zipped files in Amazon S3. Let's switch gears from security and the features and details into the greater details of different components of the platform itself. In this slide, we are just showing how we are collecting inputs for marketing ROI analysis that our end users are submitting. On the left-hand side, you see a user interface where any marketing end user would come in and submit the request, basic parameters such as what is the marketing campaign that they want to analyze, when was this campaign run, and specific criteria on how we match on downstream outcomes. The inputs from this interface are staged in a DynamoDB. We also have a batch process running every 5 minutes, which looks for any user inputs in DynamoDB. And if it sees a new request, it will change the status of that request to in progress, and then kick off the scripts to pull the data from Redshift and push it in S3. We currently allow up to 10 concurrent requests to be processed using this solution. For ML model runs, it's a simpler process. We have batch processes running that kick off on a fixed schedule, and then it runs the scripts and pushes the data in S3, input data for our ML models in S3. Here's a quick overview of the user interface that our marketing end users use to submit the request. As you can see, there are some basic parameters that they need, and they just click submit. At the bottom, you can also they can also see what are the requests that they have submitted and what is the status of those requests. Now, moving on to the next component of this platform, which is processing, right? We have our Python script sitting in Amazon S3, and we directly submit jobs to master yarn using Spark Submit through SSH. We define the deploy mode to be cluster mode, and other parameters such as number of executors, executor memory, and then the number of cores per executor that we need. There are other ways to submit Spark jobs, such as EMR step. You can also use Lambda to submit EMR step jobs, or you can set up even AWS data pipelines to do that. As part of the processing, the data from S3 is loaded as data frames in EMR for further processing, such as feature extraction, outlier detection, and model runs, etc. We also have multiple models running on a daily batch, as I mentioned, and the EMR cluster is set up to auto-scale with rules such as percentage memory available to yarn so that it can auto-scale and handle any of the peak computing workloads. In this slide, we are just showing the flow of output. The output comes to S3 and is distributed to different locations. It goes to Amazon Redshift so that it can be merged for enriched reporting and metrics. We also have third-party integrations for a lot of our ML model-based segments so that it is available for marketing users to use for targeting. And lastly, we send an email to our marketing end users who submitted that request that, hey, these are the analysis results. Here's the sample email of the econometric analysis that we run. And then this is the email that any marketing user should expect. Like there are some of the operational metrics. And then in the second table is where the analysis output is that, hey, what was the campaign revenue, how much incrementality that campaign drove, and what was the confidence interval around that estimate. How does the data science team work with this platform? We have a dev environment, and we use S3-backed web-based Zeppelin notebooks for building our analytical and ML scripts. We use SSH Bastion host to connect to these Zeppelin notebooks. And once the development is complete, we save those scripts, move them in production to submit as Spark applications. So here's the full platform that we talked about, like the different components of the platform and how the data science team interacts. Means this is by far nowhere near complete. Means we are still on this journey. We are going to continue to iterate on it. We have a lot of planned enhancements on top of it. But here are some of the benefits of the platform that we were able to realize. Over 500 plus requests have been submitted by our end users since the platform has been launched. And if some full-time resource was working on this manually, it would have taken 2+ years to complete all those requests. We were able to process those within an hour most of the time, and send the results back to our marketing end users. And from our ML model output from targeting, we have seen 173% increase in engagement rates as part of personalized marketing as measured by A/B testing. Where are we going next? This was an interesting topic. Means as we were building this platform, there were few key things as we talked to different folks internally in the team. One of the big things is that we are currently processing data which is warm and cold. We want to make sure that this platform is channel agnostic. It is able to process data real time as our next generation ML solutions. So we are planning to use Amazon Kinesis streams to do the real-time streaming of data so that we can process it immediately as needed. The other one is event-based triggers, using Amazon Lambda, AWS Lambda to trigger based on certain events. For example, when users are submitting the request, we can use Amazon DynamoDB streams to trigger Lambda functions to trigger rest of the jobs and the scripts. The third one is more for our BI team, business intelligence team, to build a data lake with Amazon S3 as the primary data source and central repository for various needs. Some of the lessons learned, like security, there are a wide variety of tools and best practices documents available. There are reference materials that saved the day for us. Means it helped us a lot to learn, especially about VPC, encryption, EMR security configurations. Past reInvent sessions on fundamentals, deep dives helped a lot. Blog, reference architectures, AWS service documentation pages. It is still a journey. It's still far with many planned enhancements that we need to do as part of this platform. But it's a journey. It means, as Amit mentioned, we have been on this journey for the last 4 or 5 years. We have continually iterated on it and are continuing to solve the problems that are coming as the next gen. Summary of what we discussed so far, like evolution of our journey from data collection to deep analytics, to problems on scaling and automation, AWS infrastructure that we use to solve those problems, and where we are going next. I do want to thank you all for taking this time to spend with us and learn about our journey, and we'll take any questions. I think we have finished way early than we anticipated, but we are happy to take any questions from the folks.